Welcome platform architects, engineering leads, and everyone looking to build the future of software to this explainer. Look, if you've been anywhere near the tech space lately, you are probably drowning in the current buzzword bingo of generative UI. Literally everyone is talking about it, but pinning down exactly what it means for enterprise systems, well, that's a completely different story. So let's dive into this, cut through the chaos, and figure out what this actually means for you and your teams.
To really wrap our heads around the current landscape, let's put a face to this. Meet Priya Nair. She's a platform architect at a mid-sized logistics company, and her story hits incredibly close to home. She was asked by a board member to evaluate some kind of generative UI thing for an internal support portal. But just 3 vendor calls in, she was completely lost. She'd heard the exact same phrase mean 3 entirely different things: an LLM writing raw code on the fly, a tool returning a pre-approved form, and a declarative blueprint for a mobile app. Nobody bothered to explain which one she was actually supposed to be evaluating. If you felt this exact same immense frustration navigating vendor definitions, you are absolutely not alone.
So let's just ground ourselves with a baseline of truth right here. What actually is generative UI? As an umbrella term, it refers to interfaces. Think your forms, tables, charts, or dashboards that an AI agent builds or assembles at runtime. This isn't just a minor update. It is a massive paradigm shift. Instead of a developer meticulously hard-coding every single screen in advance for every possible scenario, the AI interprets what is needed at that exact moment and produces the relevant interface on the fly.
Here is our roadmap for this explainer. First, the generative UI confusion. Second, 3 competing UI standards. Third, the framework layer explained. Fourth, the enterprise risk profile. And finally, number 5, controlled generative UI.
Part 1. The generative UI confusion. Escaping the engineering tax.
This whole thing really boils down to scale. Think about a standard support team. They might bounce between 40 different internal tools all day long, hand building and, more importantly, maintaining a custom front end for every single one of those tools. That is a permanent, exhausting engineering tax. Generative UI completely wipes that tax out. Instead of a developer describing an interface twice, the interface just flows dynamically from the tool's own declared inputs and shape. It's an incredibly elegant architectural pattern that frees up your engineering resources for the things that actually matter.
Moving on to part 2, 3 competing UI standards, mapping the protocol territory. Right now, we're looking at a massive protocol showdown with 3 distinct approaches emerging. First, you've got Anthropic's MCP Apps. These are totally vendor-neutral, built for any MCP-compatible client. Then, on the flip side, you have OpenAI's Apps SDK, which is highly scoped. It's laser-focused on distribution strictly inside ChatGPT's massive user base. And finally, Google's A2 UI, taking a declarative blueprint approach built for consistent cross-platform rendering across mobile and desktop. The real answer to which one is best entirely depends on who you are building for. Are you building a vendor-neutral tool? Are you trying to reach ChatGPT users? Or do you need consistent mobile and desktop rendering?
Part 3. The framework layer explained. Abstractions above the protocols.
To clear up a ton of developer confusion here, we really need to talk about an epiphany from a senior engineer named Marcus Webb. He spent a solid week evaluating agent frameworks and had this vital realization. He was looking at AGUI, which is the protocol running underneath frameworks like CopilotKit, and wondered, wait, is this just another MCP? Well, actually no, it's not. Here's the absolute key takeaway. MCP standardizes how an agent calls tools. AGUI standardizes how an agent talks to the front end that is rendering its output. They aren't competitors at all. They solve completely complementary layers of the agentic stack. Truly understanding this saves teams massive amounts of redundant integration effort.
Part 4. The enterprise risk profile. Arbitrary code versus governance.
I want you to really stop and think about this for a second. If you're using fully unbounded, open-ended large language models to write raw markup for your internal company tools touching real, sensitive enterprise data, what happens if the model just generates something malformed? What if it renders a button or a text field that literally nobody explicitly approved?
Look, fully open-ended generation, it is a fantastic feature for a flashy consumer demo. It looks like magic. But for internal systems, it is an absolute, unacceptable liability. When an LLM writes raw component code on the fly, the outputs are wildly unpredictable. It completely bypasses your explicit UI approval processes. For any security review team at a large enterprise, an agent writing arbitrary code is an absolute nightmare. They simply cannot sign off on an interface where they can't guarantee what will actually be rendered on the screen.
So the obvious solution to that security nightmare is a governed approach. Instead of the AI writing raw code from scratch, the agent selects from a fixed set of pre-approved UI blocks. We're talking your standard forms, tables, and charts. Every single one of those blocks is already vetted. It's already tested. It completely respects your existing role-based access controls. It is strictly schema-driven, meaning absolutely no arbitrary code is ever rendered. This instantly solves those massive security headaches we just talked about.
Part 5. Controlled Generative UI, the governed middle ground.
Let's actually walk through the mechanics of this, using Artificial Wit's MCP App UI as our prime working example. It's an incredibly elegant, simple workflow. Step 1. The tool defines its API input schema, the fields, the types, the required arguments. Step 2, the agent simply selects the matching block type from a fixed vocabulary. And Step 3, the governed UI automatically renders, and it does so based purely on the user's existing access rules. So a priority dropdown that a support rep sees can look completely different from what a manager sees without anyone hand-coding two versions. The generation process never steps outside your established rules.
This highlights a massive divide in how we implement these systems. Protocols like MCP Apps or A2UI generally share an assumption. They are built for the marketplace model. They're built for software like Canva or Figma, tools meant to be discovered and published to external users. But let's be real. Regional insurers and logistics companies absolutely do not need marketplace distribution for an internal claims portal. Internal systems need governed UI. They need tools tied directly to existing role access that will never, ever be publicly listed.
Which brings our narrative full circle, right back to Priya. Look at how she ultimately solved her company's problem. 6 weeks after those messy vendor calls, she made her board recommendation. And she didn't just walk in and say, hey, let's adopt generative UI. Nope. She said, adopt the controlled version, where the AI never writes arbitrary interface code and only assembles from a governed set of blocks. Grasping that exact distinction between open and controlled generation is what empowered Priya to successfully secure her project's budget. It was the only version the security team would actually sign off on.
So I want to leave you with this final, provocative thought. As you map out your AI roadmap for the coming year, ask yourself, does your internal tool really need an open-ended marketplace model with arbitrary code generation? Or does it just need a governed, schema-driven UI that your security team can actually trust? The category is officially set, but the version you adopt, that is going to dictate the security and success of your enterprise for sure. Thank you so much for joining me on this explainer, and I hope this helps you build safer, smarter tools